Hello students, let us look out the next concept of acid and bases. The next concept is bronsted theory of acids and bases. So RNAs we study student that is in aqueous solution or in water it give the acid give H plus ion and bases give hydroxyl ion. But what about the according to Bronsted theory student, a substance which can donate proton is known as an acid. A proton donor is an acid. So here is no word about the solvent student. Okay, direct if the substance is giving to the a proton, that will be acid. A substance which can accept a proton is known as base. A proton acceptor is a base. The transfer of proton from an acid to base known as the neutralization or protolysis in the reaction. So here the neutralization reaction is what student, that is transfer of the proton to the other substance which can accept, that is the neutralization reaction. But in case of Arrhenius theory it was the that is the reaction between acid and base to give the salt and water, that was the neutralization reaction. Here if you see student, acid base reaction are reversible in the reaction. HCl plus base, it is acid plus base. So whenever the acid and base is reacting, it is again giving the acid and base. That is what they are saying, that is the acid base reaction are reversible in reaction. So HCl and H3O plus are bronsted lowry acid. Okay. And H2O and Cl minus or bronsted lowry base. A pair of acid base which differ by the single proton is known as conjugated acid and base pair. A pair of acid and base which differ by the single proton is known as conjugated acid base pair. So NH3 H2O, it is giving NH4 plus plus OH minus. So that is they are the conjugate acid base. NH3 add proton, so it is conjugate base. It is base and this is conjugate acid. So conjugate acid and this is the acid and base. So if you talk about H2O and NH4 or bronsted lowry acid, so H2O and that is NH3, this is the bronsted lowry acid, and NH3 and OH minus are bronsted lowry base. The removal of proton from bronsted lowry acid give its conjugated base. So if you are removing the proton, it will give the base. If you are removing the proton from acid, it will give the base. So conjugate compound minus H plus ion, conjugate base. The conjugate base of HCl is Cl minus ion. Conjugate base of H2SO4 is HSO4 minus. Conjugate base of H3O plus is H2O. Conjugate base of H2PO4 minus is HPO4 2 minus. The addition of proton, the next point is the addition of proton to bronsted lowry gives conjugate acid. So compound plus H plus ion conjugate acid. The conjugate acid of NH3 is NH4 plus. The conjugate acid of PO43 minus is HPO42 minus. The conjugate acid of OH minus is H2O and the conjugate acid is of H2O is H3O plus. The conjugate base of strong acid is weak base and HCl is strong acid, so Cl minus is weak base. The conjugate base of weak acid is a strong base. The conjugate base of a weak acid is strong base. Okay. Now like CH3 C double O minus is weak acid, so CH3 C double minus is strong base. The conjugate acid of strong base is weak acid, that is OH minus ion is strong base, so H2O is weak acid. The conjugate acid of weak base is strong, C2H5OH is weak base, so C2H5OH2 plus is the strong acid. An acid which show greater tendency to donate proton is strong acid like HClO4, H2SO4, HNO3, etc., which can easily donate proton. An acid which show less tendency to donate proton is a weak acid like acetic acid and HCl. A base which show greater tendency to accept proton is a strong acid. A strong base like that CH3 COO minus Cn minus. A base which show less tendency to accept proton will be weak base like Cl minus NO3 minus. The species H2O, HClO3, HSO4 minus, NH3 can act both as a bronsted acid and base. Bronsted acid and base. So H2O conjugate acid H3O plus and OH minus conjugate base. HClO4, H2CO3 and CO3 2 minus. HSO4 minus H2SO4, this is the acid, and SO4 2 minus base. NH3 NH4 plus is acid, NH2 minus is base. So this were all about the Bronsted-Lowry theory of acids and bases, student. Thank you so much for watching.